Hey, hello there. Today's Leetcoding challenge question is called a dungeon game. The description about the problem is pretty long. Let me try to give a summarization. We have a 2D grid. That's all the positions we can be in this game. We have a princess on the bottom right, and we are starting out as a knight on the top left. Now our task is basically try to rescue the princess by fighting through the dungeon. Since that we are a good player, we have to maintain a positive health value throughout our journey. Note that there are some values on the locations. That's the health we will lose or the health we will gain if we go through that. So now the task is basically finding the optimal strat so that the initial required health value is minimized. So that's pretty much the problem. Oh, now moveset is that we can move to right or move down. That's only two possible directions we can go. So that's pretty much the question. So let's think about this question in a more top-down kind of fashion, because we really are solving a special case in this game because we have the initial location. What if we randomly drop in the game? We want to solve this in a more generic way. Is that let's define this function to be Fij, which is the minimum health required to save princess if we spawn at ij. Let's just look at a few values here. To solve this question is basically return f00. Let's look at the board here. So one really quick value we can look at is f22. That's if we directly spawn in the boss fight room. So the health required is 6, because after the boss fight we'll lose 5 points of health. So we want to make sure that our initial health, if we spawn at the 22, is 1 larger than the deduction we'll get. So it's easy to figure out f22 is 6. Then let's just look around and figure out the other numbers. The other number that's quite easy to figure out is f12. So we'll gain 1 health in that position. The next step, all the positions we can do is just to go to the boss fight. So we will get so this initial value +1 subtractify has to be larger than 1. So this subtractify is going to the boss fight. The 1 is the spawn location, give us 1 health for free. So figure out this calculation here. We need at least a 5 to survive if we spawn at 1-5. So that's basically what that's f22. Subtract the grid value at 1-2. If you look at f21, we'll get almost like a cheating amount of health by entering there. So that's we want this to happen. So basically we want this to be larger than or equal to the right hand side, which is f22. So this x can be some negative number, which doesn't make sense. So we just take the maximum between 1 and this required x. So it's going to be maximum between 1 and this. So we can see that we need a 1 here. So let me actually just try to populate this as well. So this is the dungeon. And then our Fij value look like 0, 1, 2, 0, 1, and 2. So in 2.2, requirement is 6. The requirement here is 5. Let me try to make this a little bit better. Follow the same pattern I have seen here. It's the maximum between 1 and 5, where this 5 is from x plus 1 is larger than or equal to f22, which is 6. If we solve for the x here, it will be 5. So it's taking the maximum between 1 and 5. That's the 5 here. So that's f12 and f21. It's easy to figure this two out because the immediately next step is directly go to the boss fight. So that's why they are easier to figure out. The easiest is definitely f22 because we have to survive the boss fight. So let's put the number here. Then we're just going to look at one more example. We can figure out the generic formula. Let's look at the 1-1. So if we're at 1-1 here, what's the value here? We can look at the right hand side and look down to see which pass require the minimum amount of health. So that's 2-1 here, because we only need 1 health when we reach 2-1 in order to be able to successfully rescue the princess. That's what 2-1 is meaning here. The minimum health required to save princess if we starting at 2-1 IJ. So we won't go to the minimum among the 2 possible choices. We won't go down here if we are at 1-1. And we just need to get there with the minimum amount health that's required for that position. So what we want is to take the maximum between 1 and x from x plus not plus 30, x subtract 10 is larger than or equal to the minimum between f12 and f21. So that's pretty much our recursive relationship. We just would generalize this a little bit with the ij here. Plug ij back in here. That would be I and j plus 1. This will be I plus 1 and j. And here the cell value basically is the we are adding the value from dungeon I and j. Yeah, so that's the recursive relationship if we go for the top-down kind of approach, or we can go from the bottom-up. Basically, it's the populating this Fij value, starting from f22 and populating everything up. So that would be the bottom-up tabulation approach. And once we reach 0, 0, we can just return that value. So it's a 2D DP, but notice that the relationship here, to calculate every cell, all we need is to look at the right-hand side, look down. So we can potentially do space compression to reduce the space required to be a single row or single column for the DP solution, a bottom-up solution. So yeah, so that's pretty much a summarization about how we approach this from the top-down recursive relationship to the transition back to the bottom-up approach. Yeah, bottom-up is basically from 2, and populating all the values to 0, 0. One trick we can do here is to, because notice that if we really want to do bottom-up, we might need to populate the last row and the last column, because we don't have to take the minimum. A quick fix is to basically pad 1 extra column and 1 extra row there, and just have those values to be really large. So if the taking the minimum between the the next one and the bottom, it will always choose the valid path. So that's just a little implementation detail. So today I'm just gonna try to code the 2D version because I'm really tired right now. So let's code this thing up. gonna grab the number of rows and number of columns for the dungeon. Oh, I have a misspelled here. And then we're populating this 2D table. Instead of calling it Fij, I'm just going to call this HP. It's more intuitive. I'm going to define a maximum integer. So we pad this 2D grid by one column and one row, so that we can just use one single formula to fill out the whole thing. It's going to be for one extra column, one extra row. Yeah, then we basically using this formula to from number of row, number of column, all the way back to there. Oh yeah, one thing we need to do here is that we need to pad one more thing. We have to pad a 1 here and 1 here. So that just says we need at least the 1 health one after we finish the boss fight. So we can. Do we need this? No, we don't need this. We don't need to populate this. We can directly fill out the value here, right? Yes. Let's just try to do that instead. It will look nicer. So HP at the boss fight, after the boss fight. Will be maximum between 1 and the whatever the health scan we will have after that. So it will be if this is a free 5 health up, that means we only need 1. If it's a negative, that means we have to have 6. So how do we fix this? So it's 1, and subtract the value there, cell value. So it's 1 subtracted by 5. So it's dungeon -1, -1. So this is the initial case, base case here, the very last cell. It's not aligned anymore. I'm just gonna comment this is base case. So then is the looping to populate everything else. Oh, it has to be subtracted by 1. Sorry, we padded 1, and if we put non-row, it's actually the last row. So we were looking at the last, the one prior to the last. So it's this, and yeah, that's it. This is the very last cell value. That's true, but this one we have to go one beyond that. So it's this. So we are looking at the very last row, the row prior to that, and all the way back to the top. And for the column, we're looking at the rightmost column, and all the way towards the left. We're populating this in this way, because every time we do this update, we have to look right or look down. So we have to populate the stuff on the next on the row in the bottom or on the column towards the right. We have to populate those first. So that's why we iterating over the indices in this way. If row is equal to number of rows subtracted by 1, we're basically gonna skip this one, or we can populate this here too. Otherwise, we're just gonna use the formula, which is this. So to solve this x, it's basically the minimum between these two and subtracted the dungeon ij. So that's minimum between HP from the same row next column, from the next row same column, and subtracted the dungeon value. In the end, we just return the top left value. Yeah, so that seems to be the code. Not defined. Yeah, so that's the code. We could do some comparison because if we look at the recursive relationship, all it depends on is the next row or next column. So we can save some space and convert this to a 1D DP if we really want. I had to go. I need to make breakfast for my kid. So that's it for today.